Good morning.
Good morning, sir.
Good morning,
Yes,
sir.
sir.
Good morning,
Good
sir.
morning, sir.
Morning,
Morning,
sir.
sir.
Good morning, sir.
Okay, good morning. So in the last class, I have given a question based on formation of the differential equation. All right. So I hope आप लोगों ने कर लिया होगा questions. So that means most of the, because it was in the last class actually we have explained what is actually the differential equation is, how to find the order of differential equation. This whiteboard is visible, no? In the last class lecture is visible, I think.
Yes, sir.
Okay. So differential
Yes, sir.
equation. Then arbitrary constants. This is of recapping all these things. What is the kind of the solutions, that is the general solutions, particular solutions are there, and then find the order and degree, then formation of differential equation. So one question I have solved this, then second question also I solved this, and 3 and 4 questions I have given. All right, so these are the 3 questions I have given. Some more questions are based on that, formations based on that. And now I'm also writing one more question, question number 5. Find differential equation of a into y plus a ka whole square, this is equal to x cube, where a is an arbitrary constant, arbitrary constants. All right, all right. So this is the 5th questions. So I hope you did this question. The question number 3, what is the solution of that? Question number 3. Yeah, raise your hand.
Sir,
Then you tell me. Raise your hand and then you tell me, oh, what is the solution of that one. A plus bx e to power 2x. What is the solution? Okay, who will tell me? Divyani, yeah, please tell me.
So d square y upon dx square minus 4 dy by dx plus 4y is equals to 0.
Okay, I'm writing the answer here. D square y upon dx
dx.
square minus 4 dy by dx, then plus 4y equal to 0. Is it correct now? No?
Yes,
Yes,
sir.
sir.
Yes,
Okay,
sir.
fine.
Yes, sir.
And what is the question number 4? What is the differential equation for the question number 4? Anyone who did this question number 4? Solutions 4. Otherwise, I will do that. So we're going to
I think
start.
question number 4, y is at origin. matlab, the circle meets the y-axis at origin.
Yes. Form a
X.
degree of a differential equation of a family of a circle whose center are on x-axis and which touches the y-axis.
Yes, sir.
Sir, y square minus x square minus 2xy y dash is equal to 0.
Yes, sir.
100%. 100%.
Yes, sir.
X square minus y
Maybe,
square plus 2xy
okay,
dx equals to 0.
no issue. Maybe somebody has a problem to solve this question. So just I'm trying to find the solution now. What is the center of that? Suppose I am center is taking the center is C and 0, of course. So what is the radius? Radius equal to
C or
right?
A.
So the family of circle is or the equation of the circle is x minus a and square plus y minus b ka whole square equal to c r square. That is the equation of that, right? X minus a square plus y minus b square equal to r square. So x minus c square and then plus y square equal to c square. Fine. So c is the parameter. So now when you differentiate it, first when you differentiate to eliminate, I'm writing here differentiate this equation 1 to eliminate c, because c is the parameter. All right, this is a constant parameter, constant. So we have to eliminate it. When you differentiate it, the equation will be like this. This either C should be eliminated, and then using 1 and also using 1 and 2. So that means when you differentiate equation, this will be equal to 2 into x minus c plus 2y dy by dx equal to 0. So taking these two equation, and then you have to eliminate c. So when you eliminate, because 2 into x minus c, and here c is there, so when you put this value x minus c equal to minus 2, this 2 and 2 cancel, so x minus c equal to y minus sign dy by dx. You just put it here value, and then you eliminate. The equation will be reduced into the form of so I'm writing here using 1 and 2, and 1 and 2, when you put this value here, the whole equation will reduce to the y square, and then this will be minus, of course, x square, or we call it equal to x square plus 2xy dy by dx. So this is your required differential equation. All right, easy na? Easy.
Yes.
Yes,
Okay.
sir.
So I'm going to the next sheet. The solution of first order. Your course is first order, first degree differential equation. So I'm going to that part. So come to there. That is important. First order, first order and first degree differential equation. So I'm going to use the new sheet, blank sheet. This one I'm using this. Come to this one. Solution of. So this is the course that is going to begin today. The solution of first order and first degree differential equation. All right, differential equation. So I've already explained what is the already differential equation, what is the order, and what is the degree of the differential equation, how the differential equation look like. So the first segment of the syllabus is that which concerned with the for yeah, Kadam Tripathi, you want to ask anything because you have raised the hand? Ayush Kumar, Kadam Tripathi. Okay, fine, thank you. So everybody is present in the class. 71 students present in the class. So I should take the attendance first. Download. I am downloading the attendance. Okay. Fine. Then come to that part. Now the question is that just defining the first order. The first order and first degree differential equation contains, and what is the standard form? So first order and first degree differential equation contains only what contains only dy by dx. Sometimes it is also called y dash. All right, or this is y to power 1 or something like that. The known function y, the known function of x, and perhaps maybe somewhere perhaps terms of y itself, somewhere itself, because it's not necessary that the y should be there, because we have already derivative of the dependent variable. So it might be possible that the y should not be in that equation, but the degree 1 and degree first order and first degree should be. So the general form is the general form of differential equation, this first order first degree, is this we can represent it f of x comma y and comma y dash. This is equal to 0. So this function indicate that there should be x, maybe your y and y dash will be there, or we call it dy upon dx, and then plus the function of x comma y, and it will be equal to 0. So this is the standard form, the general form of the first order and first degree differential equations, right? Now the question is, what are the methods to solve these equations? Standard methods, standard methods to solve this equation, standard methods to solve these equations. So we have the number of methods to solve these equations are, yes, and this can also be written like this. Now see, if I have to write this equation, can also be written like that, m, because when dx will multiply, so there should be something like that. So dm, so m dx, and then plus n dy, n dy equal to 0, where m and n are the function of m, n are function of function of function of x and y. So this is another way of representation of this first order first linear or degree differential equation. Now what are the standard, please mute yourself, standard method to solve the differential equation? What are the standard methods? Standard methods. Now see, here I am using the first order and first degree differential equation. Next we'll go for the higher order differential equation, right? So there is another method to solve the higher order differential equation, but here we are using for the first order first. So methods are, standard methods are, come to that one, standard methods. So am I audible now, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So don't say everybody yes sir. ऐसा नहीं है कि सर के बहुत ही खास है इसलिए, because if one can okay, I will ask others if the name is coming first on the mechanical. So the first or second person, Ashish Rose is also there. So mute Aditya, mute please. I will take your name here if you will not mute. Right, because this create the problem in the class for the 71 students. So you should be in the discipline. Okay, so I will ask anything else, I will ask with the name, no issue. So the standard methods are number one, and the number one method is what? This is called the variable separable method. You have to remember, it's a very easy method when we solve this problem. Variable separable, the name itself shows what is actually variable and separable. We have to separate the variable. The variable separable method, variable separable method. Then the second method is, this is called the homogeneous. If equation is in homogeneous method, homogeneous form, homogeneous equation, and then homogeneous differential equation. I'm writing here homogeneous equation. So if the equation is in the homogeneous form, I will show it as a standard form when we call it a homogeneous equation. Then we have to reduce into the variable separable form, and then we can solve it. Third method is non-homogeneous differential equation. Non-homogeneous differential equation, reducible to homogeneous form, homogeneous equation, homogeneous equation, or homogeneous differential equation. Fourth part, this is called the exact form of differential equation. Exact form of differential equation, exact form of differential equation, exact form of differential equation. Then the fifth is non-exact form, because just like homogeneous is non-homogeneous, exact is non-exact. I will explain each and everything first. We will start non-exact differential equation form. can be made exact, can be reducible to exact form, and we have to reduce this by just writing it in the bracket using in integrating factor. This is one of the integrating factor, right? Integrating factor, we should use it like in the chemistry, you know what is that, something a litmus paper and that can
Bent off
make it,
factor.
yeah,
Bent off factor.
yes. Then 6 integrating factor is there, then 6 is a linear differential equation. And I hope that 2 or 3 method that you have already gone through in class 12th. I think variable separable method, homogeneous, and linear equation, linear differential equation. I think 3 I remember, and even the students are also sharing the class differential equation, differential equation. Okay, that means this I will mark it. I will mark it. Maybe you have gone through, but I will teach you is an advanced way. This in a very clear way. If it is not clear, the variable separable method, homogeneous, and linear differential equation. These 3 methods that we have already gone through in class 12. In class 12. So 7, come to the 7th part. This is called the nonlinear or called the Bernoulli nonlinear differential equation. Sometimes it is also called Bernoulli equation. Bernoulli's differential equation. So this is one. Okay. Yes, Aditya IT and Aditya IT. They are in the class. Aditya is not in the class. I will remove from the class if
Yes,
you will
sir.
not respond. So if you will not respond in calling of 2 or 3 times, then I will remove from the class because this shows that you are not sincere in the class. So Aditya, have you gone through any method at class 12th? Remember? Yeah. Okay. Not remember. Okay. No problem. Mute yourself. Mute yourself. Vishnoi, Abhishek, Vishnoi, Tanvi. Okay. Tanvi.
Yes, sir.
Yeah. Have you gone through any method at class 12th?
Yes, sir. Variable separable,
Uh,
homogeneous, and linear differential equation.
yes, exactly. What the students are sharing in my class. So variable, separable, homogeneous, and all. Now see what actually we will do that right here. So mute please. The variable separable, we have to separate the variables x and y, and then we apply the integrations with respect to derivatives. Homogeneous, if the equation are in the homogeneous form, if the every term has the power same, then we can reduce into the variable separable form and then we can solve it. This is the one way. Non-homogeneous, that means we have to change into the homogeneous form and then we apply and then again we go for the variable separable form. Another way, that is the exact form, it is there is a condition that it follows the condition, then this shows that this equation is in exact form, and there is some method directly we can find the solution of that differential equation. Similarly, in the non-exact differential equation, we have to reduce this non-exact into the exact form, and then we solve by using the exact method. What the methods are for the exact solution to find the solution of differential equation which is in the exact form, we can apply that. It's very simple. Then similarly here it's a linear differential equation. We have to find the integrating factor and then multiplying that, and then we can solve this. This is very easy and we have already gone through that, but I will solve so many questions. Many questions I will solve it. Then again for the non-linear, that is the Bernoulli form of differential equation, we have to reduce into the linear form, and then we can solve it by linear methods. So whatever the methods are there, we can solve it. So this is the crisp that the standard methods of. There are 7 methods that we can solve the first order, first degree differential equation. Fine. So going to start the first method, that is the variable separable method. Going to start this variable separable methods. So come to the first method. First one, this is variable separable method. Separable method. Separable method. Okay. So the standard form is that how we can solve it. We have, if the differential equation, I'm writing, if the differential equation that is in the form of can be put in the form of this form of, like f of x, and then this is the dx. This is equal to phi of y into dy. What this indicate means, or we can also say, or just I'm writing here, or m dx plus n dy equal to 0 or equal to minus m dx. So here what, f is the function of x and this is the n is the function of y. Now see here, it should be the function of x and it should be the function of y. Then we can directly integrate. Yeah. Then the solution then the solution can be obtained by integrating both sides. Because you know what is explicit function and implicit function. I'm using the right side here. What is implicit function and what is implicit and what is explicit function? What is explicit and implicit function? Who will tell me? Anyone can tell me? One, raise your hand. Explicit and implicit function. Yes. Okay, Vinod Kohli, please tell me what is the implicit function?
Sir, my name is Rinda Kohli, and
sorry, Rinda Kohli. Sorry.
yes, sir. Sir, an implicit function is one in which we cannot completely separate the terms of x, y, and the differential. We cannot completely separate the terms.
We cannot separate. That means we cannot represent the equation y in terms of x or x in terms of y. Yeah, is it? Is it na? Rinda?
Yes, sir.
Okay, so that is the implicit function, and here it is an explicit function. Means if we can separate the variable and its derivative or its operator, so this makes like a explicit function, right? Fx and dx, fy and phi y and gy. So directly we can integrating both side, integrating both side separately, or we can separate. The solution is just we're integrating. So integrating of f of x and then dx, and this will be equal to integration of phi of x, phi of y, and then dy, phi of y and then dy. And using this integration means we are using a one constant c, where we can write it where c is an arbitrary constant. All right, so we can say like that. So if it is an explicit function kind of that, we can separate by using the separable variable method. We can do that, and we separate the variable and directly we can indicate both sides. So this is the one way. It's a very simple way that we can. So we have to look where, because the method will not be given in the question. The method should not be mentioned in the question that yeah, you solve this question by the separable variable method. No, you have to look that question, you have to check it. So you have to scan the question that whether we can apply or not. Can we reduce into the separable variable separable form? If it is not, then we can go for check for the homogeneity. If it is not, then we can check for non-homogeneity. If it is not, then we can go for exactness. If it is not, then we go for non-exactness. If it is not, then we can check for linearity. If it is not, we can check for the Bernoulli. So these are the 7 methods. So if the thing should be clear, the fundamentals should be clear, then you can directly see, just to watch the problem and you can solve that question, right? So I will give you my remarks also here. So before that, going to start one question. Question number 1. Solve the differential equation. This is not mentioned. The method is not mentioned. That is another matter that yes, the only one method is going on. That means of course this question can be solved, but actually it is not mentioned. 3x squared minus 5x and plus 1. Yeah. So is it looking like that? Dy by dx equal to 3x squared minus 5x plus 1. So by solution, by using the variable separable, just separating that equation, so we can write it dy equal to, because right side only the functions are x, this is the function of x only, and the constant, so we can write it this 3x squared minus 5x and plus 1 into dx. Is it okay? So this is equation number 1. So this is the using the variable separable method, using variable separable method means what? We are integrating both side, integrating both side, and we can integrate it. So integrating both side means dy, and this will be equal to integration of 3x squared minus 5x plus 1 into dx. Yes, we can integrate. So this will be equal to y, and this is equal to 3x cube upon 3, then minus 5x squared by 2, and then plus x plus c, or this implies that we can say that this will be y equal to x cube. This will be cancelled. So this will be equal to x cube minus 5 by 2 x square plus x and then plus c, and this is the solution. Is it okay?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So Pranjal Paira. Pranjal is there? Pranjal, not there. Pothu Raju.
Yes, sir. Yes, sir. Yes.
Yeah, is it okay now?
Yes, sir. Yes, sir.
Achha, Pranjal, tell me, this solution that I have obtained using the variable separable method, it is a complete solution or a particular solution?
So not complete. It's but yeah, we need to find the value of c.
So it is a complete, or means it is a general solution, or this is a particular solution?
General solution.
Okay. Are you sure?
Particular solution.
Particular solution. Sorry, sir.
Particular solution. No. Pothuraju. Pothuraju is there?
Yes, sir.
Yeah, Pothuraju, please tell me. It is a. Is it clear now? Solution way that I have solved the
Yes,
question.
sir. Yes,
Okay,
sir.
so it is
Yes.
a particular solution or general solution?
It is a general solution, sir.
Why it is general solution?
There is no particular value for C, so that.
Okay, okay. Rohan is raising the hand. Yeah, Rohan.
Good morning, sir.
Good
This
morning.
particular solution is a general solution.
Particular solution is a general solution.
So this solution that you have taken out is a general solution.
Okay, why?
So because for a particular solution, we need to have some specific value of C.
Yeah, 100%. Good.
We
good.
don't have that value, so it will be considered as a general solution.
Fine, good. Jalaj. Okay, fine.
Sir, this is a general solution.
Fine. So it is a general solution because we don't have the value of see here. So I'm giving you one more question, and you have to solve this question, everybody. And let's see. You raise your hand when you solve that question. I will ask the answer. Right. So this method is clear to everybody, I hope.
Yes, sir.
Question number 2. Solve differential equation. This x square minus y x square. I have the question bank also, based on all the methods, and even I have solved that question bank, and it is of 28 questions I have here, and I have solved all these questions. So this is a good for you in my section, that I will give the kind of this question bank and also the solution of that. We'll solve first and then we'll give you.
So can you upload the question bank
No,
on
no,
the
no,
file?
no. Later on we'll do that.
Okay.
As the time is going, we'll do that everything. X square minus y x square. You have so many questions are there in your textbook. B.S. Girwal, Shanti Narayan, and so many questions, right? Ramanna is there. So many books are there, right? And also I have in the last class, Das H.K. Das I have mentioned is again a good book. So x square minus y x square dy by dx plus y square plus xy square equal to 0. Yeah, solve this question. Giving you 2 minutes, 2.5 minutes. I'm giving you 2.5 minutes. X square minus y x square dy by dx plus y square plus xy square equal to 0. Okay, Neha Reddy, Utukuri. Neha Reddy, yeah, please tell me the answer.
So 1 by y plus 1 by x plus log y by x is equal to c.
Okay, there is a sign problem. I think I have to check it.
सर
खत्म.
log x by y आ रहा है शायद.
हाँ.
वही वो माइनस माइनस होता
Yeah. Good.
Log
But
x by
this
x
is
आ
not
रहा है.
sign. You check the sign. Antara.
Yes, sir.
Yeah, answer please.
1 by y plus 1 by x plus log y by x equals to c.
Okay, Rijul.
So same as Andra has suggested, 1 over x plus 1 over y is equal to log x minus log y plus log c.
Okay. So this way we are taking the y and fine. Y divided.
So I am having an answer that is 1 by x plus 1 by y plus log xy equals to c.
Okay. Column Baker.
Sir, I got 1 by x minus 1 by y is equal to log x plus log y plus c.
Okay. So I have the answer here. Answer is log x by y. This is equal to 1 by x plus 1 by y plus c.
Yes, sir. Correct.
Yes, sir, I got exactly the same.
Yes.
Is it okay?
Yes, sir.
Yes, sir.
Okay. Okay.
Yes,
So
sir.
so many questions we have. So many questions we have. Okay. Before that, I want to write here a remarks. You remember everything because the question is based on that. What is the remarks of this? If this is very important, remarks is very important because most of the questions we are setting based on the remarks because everybody is going on the streamline, but we are debating with the remarks. So it should be very important. So if an equation is in the form of dy by dx this is equal to f of ax plus by and plus c, right? So see, this f is a function of not only the x, or f is not a function of y only. If it is like that, is a function of x and y both, then the simple way is that then put ax plus by plus c, and is another variable, we call it z, right? Z. So this equation reduced to then one reduced to dy by dx, and this is equal to f of z, right? So this equation, and then solve using variable separable form, and so this dy by dx will also change, right? This dy by dx will also change. So solve using and replace z as the function of x and y. This is the way that we can find. So let's go for that question. Go for the one question based on that. What is actually this question is? So we have the question for that, and the good question we have. But before that, we have to go for one question, two questions. Okay, fine. So we have here the question like that, so that you can solve it the easy way. Okay, a simple question I'm using here, very simple question. Now see, the one question is question number 2. I'm also from the question bank. You can go from the question bank also. Question number 4. So many questions I have, but for that, okay. This question is question number so this question, one question this I will solve, and one question I will give you. Find the solution of differential equation. Find the solution of differential equation. The question is dy by dx minus x tan y minus x equal to 1. Now see, can we use the remarks here? Yes. So we apply the remarks here. So because we cannot solve directly without by separating variables. Can we apply here the variable separable method? We cannot apply, right? We cannot apply. Rohan Khanna. Lakshya Jain. Lakshya Jain.
No, sir, we cannot apply.
We cannot apply because we cannot apply the variables above. Dipanshu Joshi. You cannot apply, na?
Yes, sir, we cannot apply.
So, but we can apply the remarks so that we can it could be reduced. Fine.
Yes, sir.
So, using that one means let y minus x. This is equal to, I am using it as a t. So this is t. So this will be this implies that dy by dt, and this will be dy by I'm using the dy by dx, okay now, right? dy by dx, and then minus 1 equal to dt by dx. I am replacing with it with dx. So this implies that dy by dx, this is equal to uh, dt by dx and plus 1. So I will replace it. This is equation number 1. Suppose that, so then this equation will be from 1, this will be 1 plus dt by dx, and then minus x, and this will be tan t equal to 1, right? Now this 1 will be cancelled, so this implies that we can solve this equation here. This implies that this dt by dx, this is equal to x tan t, or this imply, or we can write it dt upon tan t equal to t into dx, right? This is, sorry, x into dx. This will be x into dx, or we can write it cot t and then dt. This is equal to x dx. Is it okay? So this is equation is a variable separable form. Variable separable form में आ गया ये.
Yes,
So
sir.
now we can integrate.
Yes.
We can integrate it, है ना? उसको हम integrate करेंगे. So integrating both side. So we will do here the cot t dt, and this is equal to integration of x dx and then plus c. What is the integration of cot t?
Log sin
Log
x.
sin t.
Log sin t.
Log sin t, and this is equal to x square by t plus c. All right. Now we replace t by what is t? T is y minus x. This implies that log sine y minus x, because t is y minus x here. X, this is equal to x square by 2 and then plus c, and this is your answer. Is it correct one?
Yes,
समझ
sir.
में आया सबको? Very
Yes,
good.
sir.
Yes, sir.
So I am giving you one more question that you have to solve. Question number 3, giving you 2 minutes, and we have only 2 minutes here for the class also. X plus y plus 1 is dy by dx. This is equal to 1. Yeah, do it fast. And with parallel, I am writing some question for the practice. Yeah, please tell me very fast. Giving you 1 minute because at 11:50 there is another class. 12:15, sorry, 12:15 class. Ayush Kumar, what is the solution?
Sir, solve it.
Okay, because you have raised a hand. Arnav Anand.
Sir,
Yeah,
so
you
the
have.
solution is x plus y plus 1 whole cube by 3 is equal to 2x plus c.
No. This is x plus y plus 1 ka whole square divided by dx equal to 1. The question is, let me check the question.
So this,
X
yeah,
plus
give
y
the
plus
solution.
1 whole square divided by dx equal to 1. Yes.
So the
So
solution will be x plus y plus 1 minus x plus y
no,
plus.
no. Yashvardhan Jaswal.
Sir, y plus 1 minus tan inverse x plus y plus 1 equal to c.
Y minus.
नहीं. Sir, y plus 1 minus tan
Hmm.
inverse x plus y plus 1 equal to c.
Yes, sir. This is the correct answer, I think.
Good, good,
Yes,
good.
sir.
Yes, sir. 1 plus y minus
Yes,
tan
sir.
inverse x plus y
Yes, sir.
plus 1 is equal to c.
Yes, sir. Yes, sir.
Y
Okay,
plus
Vrinda.
1 minus tan inverse x plus y
Yeah,
plus 1 equal
So
to
the same
wait.
answer.
Yashvardhan, wait. Neha ready. Wait, wait.
So y
Vrinda.
minus,
So
sir?
Okay. Huh?
y plus 1 minus tan inverse x plus y plus 1 equals to c.
Okay. So I'm writing the answer. Good. Good job. So, Kisko, and anybody who's not understanding this method, anyone? Anyone in the class? So please down your hands and tell me those who was unable to understand the method, variable and separable method. Anyone in the class? Rohan Khanna, you are not able to understand this variable separable method.
I was
Rohan
able to
Khanna.
understand. I made a slight
Okay,
error,
but
sir.
you have raised your hand. Yashvardhan.
Yes, sir.
Okay, anyone who is not able to understand what is the variable separable method? Parth Sharma. Parth Sharma is not able to understand, I think. Parth.
No, 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 sir. I understood. I raised my hand to answer the
Okay.
question.
So first, because I'm asking those students who was not able to understand, so
No,
that I
no,
have to
sir.
take a recap of that one. Okay, good, good to see that that you are ready to solve this question, and you have, so actually you did. So I'm writing the answer here. Y equal to tan inverse x plus y plus 1, and this is minus 1 plus c, I think. Yeah, na? Exactly y plus 1 or y minus. Is it
Sir,
okay?
Yes, sir.
Okay, so question number 4, question number 5, and question number 6, you have to solve this question, and tomorrow I will ask this the answer of this question. Fine? Is it okay now? So I am sharing this slide, this solution to your MS team, that you can go through that also. And I have uploaded 2 PPT, this MS team, in our MS team. And you have also, I think you have the link now, that how many all the lectures they have already uploaded. You got the link, I think. Yeah,
No,
Yashvardhan.
sir.
Yes,
No,
sir.
sir.
Yes, sir.
There's a
Yes, sir.
link that okay, no,
Sir,
no.
the recordings, right?
Okay,
Recording.
two lecture PPT I have uploaded in this team of BTech Festival.
We
Right?
got the lecture recordings, but not the PPTs.
Okay, okay. PPT today actually I have uploaded. You can have now. Right, in the place where you have downloaded the course handouts. There I have uploaded the two PPTs, two lecture PPT. Fine. So thank you everybody. So I'm going to stop. Thank you everybody.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
जय हिंद दोस्तों। बी कैपिटल है, बी कैपिटल है और एच स्मॉल, BHSA 7270।